hope I know you are seeing my screen. So today we shall be looking at 3 classes: reaction scheme, reaction mechanism, and reaction calculation. So we are going to start with reaction mechanism and reaction scheme. Then in the second part we shall then look at reaction calculation. So we will begin by using ChemDraw. We shall use ChemDraw for the reaction mechanism and reaction scheme. So let me open my ChemDraw. Okay, this is ChemDraw. Are you seeing my screen?
Yes, sir.
Okay. Now, when we talk about reaction scheme, what we mean by reaction scheme is just a chemical equation. Let's say you are doing a research work and your research work involves synthesis. I will share with you a lot of research work that has been done, and let's say your research work involves synthesis. And since your research work involves synthesis, probably you are synthesizing any product, it is mandatory. Excuse me. Hello. Yeah. Try the first link. Okay, just hold on. So, sorry. So I'll be sharing with you some reaction scheme. Now, so I was saying that reaction schemes are chemical equation. So let's say you want to synthesize aspirin, for instance. That maybe your project work is to synthesize aspirin. Now, in your research work, you are going to show us the chemical equation for the synthesis of aspirin. So you are going to be showing us the chemical equation. Now, that chemical equation for the synthesis of aspirin is what we call reaction scheme. So just like how you used to write the equation between acid and base to form salt and water, we don't call it chemical equation. What we call it is reaction scheme. So the process involves...
Sorry, sir. Is it scheme?
Yes, scheme. S-C...
That...
S-C-H-E-M-E.
E-M-E. Okay, sir.
Good. So so here we may not be calling it reaction equation, but we'll just give it a name, reaction scheme. So I will share with you some publications, and we'll be using ChemDraw to see how we can write that reaction scheme. Okay, let me add in somebody. So I'm coming. Let me share with us. I want to look for the file. Let me just open my with me a bit. My system is a bit slow. Okay. Well, let's just start with this. Let's start with this. So this is This is my work. I believe I shared this with some of you. I sent a message to your mail this night. So check your mail. You will see a PDF. Please, if your mic is on, you can mute your mic to avoid interference. I'm hearing background noise. Whose mic is on? Okay. All right. I've helped the person to mute it. So now let's look at this reaction now. Hope you can see the two. You can see the two screen.
Yes, sir.
Okay, so what you are seeing here, you all have this one, the one at my right, I sent to your mail. Now what you are seeing here is a chemical equation that led to the synthesis of 8-acetyl 9,10-diazo 9,10-dihydroanthracene 2-carboxylic acid. This is my compound. I discovered this compound early this year. The compound is still novel. It has not been reported anywhere. Nobody have used it. Nobody have seen it before. So you can as well copy this name and paste anywhere. You will see that the compound is still novel. So we want to see how we can now if you want to synthesize this compound, maybe I want to publish the work. It means that I'm going to, in my publication, I'm going to show the equation that leads to that synthesis. Now this synthesis is a multi-step synthesis. These people coming late. They are distracting my class. So the synthesis is a multi-step.
My boss, please, I have a question.
Yeah.
Sorry, don't say that I'm dragging us back. You know, I just joined. The information you forwarded us in the class group talked about a reaction scheme, mechanism, and
calculation.
What else again? Using
calculation.
Calculation using ChemSketch. But yes, using ChemSketch. But we are in ChemDraw.
Okay.
How come? Because I opened ChemSketch.
Okay. Now I will come back to ChemSketch. So just open your ChemDraw.
No wahala.
Yes, I will come back to ChemSketch. So if we now want to publish this work in our paper, we are going to show the reaction mechanism. So I started, when I did the synthesis in the lab, I started with 2-benzofuran, 1-dione. I reacted with benzene. So let's see how we can do this. Okay, I'll make this class easy for us. I'll make it very easy. From my experience, I will advise you if you want to do reaction mechanism, use ChemDraw. But then if you want to do just reaction scheme, you can go ahead with ChemSketch. So for the sake of, I have already promised you for the reaction scheme. So let us go ahead with with ChemSketch, but my ChemSketch is really not responding as I wanted it to respond. It's not responding the way I want it to respond. That is why I would have loved to use a ChemDraw. But let me see. I'm trying to adjust it for my personal use. Okay. Well, we are going to use it. Alright, I want to just leave me a little time. I want to adjust my window. So I want to share the screen so that I can view both my ChemSketch and the document I want us to use tonight. So I can view both of them in my side screen. Okay. So like I told you, we'll basically do three things tonight. The first one we'll do is reaction scheme. After reaction scheme, we'll go to ChemDraw for reaction mechanism, and then after the reaction mechanism, we'll come back to ChemSketch for reaction calculation. Now, note that you cannot use ChemSketch for reaction mechanism, but the features in ChemDraw are more better to be used in reaction mechanism. Although we can still try using ChemSketch for both the reaction mechanism. So let us start. So what you are seeing here is chemical equations that will lead to my novel compound. We are going to use ChemSketch and see how you can build this chemical equation. It's very simple. After you have built the equation, in your publication, you just need to put the reaction schemes. You don't need to include the reaction mechanism. But if you are preparing a thesis or an undergraduate work, maybe your full project work, you must show the reaction mechanism in your full project work. But if you are publishing just for publication, then you just need to show only the reaction schemes for your publication. Okay. So now how can we do this? It's very easy. You can draw this. I believe most of us can draw this. You just pick your benzene, click your benzene, insert it, then take this, your cyclopentane, include it together, then take your single bond at this edge, this terminus, and make it double bond, which I know you are seeing my screen. Then the next thing you do is take up your oxygen. There is oxygen here, there's oxygen here, there's oxygen here. Then you take your plus sign. This is the plus sign I've already showed you, and I believe within the weekend you must have gone through everything. You insert the plus sign. Then we are reacting this with benzene. You include your benzene. Then you know, before I'm doing this, like if it's in your case, before you do this, you must have draft the reaction by yourself, the reaction scheme by yourself. So after you must have drafted it, then you are just looking at what you have done in your paper and pen, and translating them to your drawing tools, so that at the end you can copy from here to your MS Word. So the next thing you will do is that for you to type in this, the arrow, the up is showing your reagent, the down of the arrow is showing your reaction condition. What you do is you take up this red arrow first. We'll be using these two, the red and the blue. The red is to just click and show us the reaction. Then for you to type in this aluminum chloride at the top and 70 degree at the down, you pick the blue one. The blue one is showing reaction arrow labeling. So we don't label it manually by test. We label it by using this reaction arrow labeling. So once you click on this, then if you watch the cursor, it's also showing some stuffs. You come to this arrow and click on the arrow. Let me go back.
My boss, we're not doing your screen, please. You share the screen.
I'm not if you are not seeing the screen.
No, all of us, so ensure you just started talking after a long while. We didn't even hear you talk anything. No.
Seriously, sir.
Okay, that
Went off.
that will be network. All right, let me share my screen. Okay, that will be network. So sorry for that. Can you see my screen now? Can you see my screen?
Yes.
Okay. So where did I stop? What did you hear me last? What was the last thing I was saying before you?
You were saying that compound was the one you used, the novel compound, and that was the last thing I heard.
Okay. So I was saying that I have a research work I'm already doing, and I discovered this compound, and so I want to have already done the synthesis. Now, if you also doing synthesis like some of us who are working on synthesis, there's a need for you to learn how to develop or design your reaction scheme. Then after that, you copy to your Word. So I've already done it. I just want to show you how to achieve that. So this is a reaction, and we'll be using ChemSketch to do that. You just have to draw. You just have to do this. You pick this is phthalate anhydride, or you call it 2-benzofuran 1,3-dione. So let's draw it together. I pick my benzene and I place the benzene. Let's switch. This thing will not disturb me tonight. Sorry, my ChemSketch is really not responding well. I'm coming. I want to close something.
Which one?
Sorry, my
Is it ChemSketch? Okay.
I'm using ChemSketch is slowing down because I'm running a program. But let's see how I can manage it until the program stops. So I pick the benzene. When you pick the benzene, you click. Then, of course, you can draw this. To draw this other chain, you pick this, your cyclopentane. When you take the cyclopentane, when you click on the cyclopentane, you come to the side of that benzene. You can be doing that as well. You can be doing that as well. You come to this place and attach it. Then you pick up your single bond. Pick up the single bond and just give me a few minutes, just remaining little time. What I'm running will stop. My ChemSketch is a bit slow. It's a bit slow, but it will soon respond. Okay, can I just do this with ChemDraw? I think it will be better for me until my ChemSketch responds.
Okay, in as much as you are doing it with ChemDraw, tell us what to do with the ChemSketch, how to draw it so that I can go ahead and draw it with ChemSketch.
I'm just waiting for this docking.
Because mine is responding.
Yes, so just wait. So let me try using my ChemDraw if it will free me. Okay, so I will pick benzene. You place your benzene. Okay, let me use ChemDraw. I will still come out to ChemSketch. So this is what I'm trying to do. You pick your benzene, you draw the benzene, you take up your cyclopentane, you put that beside, you take up your single bond, there's single bond here, there's single bond. Okay, you made this place double, also make it double, and then you pick up your oxygen, you drop your oxygen here, and also your oxygen here. Then you can look out for the plus sign. You can look out for your plus sign. You can go to view. I'm using ChemDraw now. Go to view. You check arrows. Okay. I'm coming. Let me get the plus sign. Just be patient a bit. Okay, no. Okay, let me just type in the plus myself. You type the plus other than wasting time. Then the next thing is for you to put your benzene. You insert your benzene. You insert the benzene. Then you show your reaction arrow. You can get that from here. You pick up your reaction arrow. You place the arrow. Then you draw the products. But actually the best to be used is ChemSketch, which I'll be turning over to ChemSketch in a few minutes time. Then for us to complete the drawing, you pick up your benzene. This is the benzene. You draw, you take this. So it is not difficult to draw. It's something you can always do on your own. Then you pick up the benzene. Okay. Here is a double bond. Here is a double bond. You can include your bond, the atoms. No. You include your atoms. At the top here, your oxygen. Here, your oxygen. And this place, your OH. So, if you are using ChemDraw, as I'm doing, it means that for the reaction arrow, you are going to type by yourself using tests. You use tests to type at the top aluminum chloride at the top, aluminum chloride. Then at the down you type your 70 degree. Now if you want this in the aluminum chloride, you can bring down the 3, just highlight, select only 3 and make it subscripts. Select the 3 and click on subscripts and it will come down. You can bring it to be at the center. Time to shift it well. Okay. Then below it, you can type in your 70 degree Celsius. If you want the degree to be up, you select it and you make it superscript, so that will be up. So what I just did now is I just developed the first scheme, because this synthesis is a multi-step synthesis, so we just develop the first scheme. You can now copy from here to your work. So you can repeat this. You can as well generate the names. You generate the names by selecting them. You go to structure, you convert structure to name. You also select this. You go to structure and you convert structure to name. Then you can pick up this. The same thing happens to this too. You convert it to name. So at this point, we just did the first scheme. You can repeat this for these other ones. We can do the other scheme. So this is the first stage of the synthesis. Then the stage 2, we can copy this and use the product of the stage 1 to continue your stage 2. So you can continue with this in your stage 2. You can copy this reaction arrow rather than repeating other ones. You copy it and you place it where you want to place it. I have copied another thing I'm not supposed to copy. Let me delete this out. So what you now do, maybe you edit the up, you edit this top and make it H2SO4. You make the H, the 4 subscripts and your 2 subscripts. Then you change the 70 degree to 200 degree. So it is not difficult one to be done with ChemDraw. It is not a difficult one to be done with ChemDraw. We are basically going to use ChemSketch also to show you. At least you cannot compare between both ChemDraw and ChemSketch, the one that is mostly preferable for you to use. All right, are you with me?
Yes, sir.
Okay, so it's a very simple one to do. Then you take up your oxygen here. You can highlight and generate the name also. So this whole process can be repeated for all the steps. So what we are doing here, we are just showing the reaction mechanism. We are not showing the synthesis. So we are just showing the reaction mechanisms. The reaction mechanism is different from the synthesis. So if you are doing publications, what they want to see is your reaction stream. So what they want to see is the reaction stream. So what they're interested of seeing is the reaction stream. But then, if you are coming for defense, probably your undergraduate or your postgraduate work, and you are doing synthesis, we would like us to see the mechanism of the synthesis. Like in this work, we have about 6 steps. 1, 2, 3, 4, 5. Okay, about five steps. Each of them we have their mechanisms. So that is what I will be showing you. But so far we have been able to use ChemDraw to build your reaction stream. So if you have a question at this part, you can do it to ask. Do you have a question on this part? Hello?
Sir?
Yeah. Do anybody have a question on the reaction stream?
No, sir.
So if that is okay by us, really checking what I'm doing so that we'll go back to ChemSketch. Now I quickly want to show you guys something. When we concluded ChemDraw, I asked for your challenges. If you could remember, most of us gave a common challenge, which I said I'm going to look into some of the challenges and see how we can provide answer. So before I move to ChemSketch, or before I continue with reaction mechanism with this ChemDraw, let me quickly show you the issues some of you had where you are trying to make a bond, the single bond to be long. Wanted to have a long bond length. It's very simple. Like you want to draw this single bond to be long. Some of you were attaching another bond which indicated error. So I figured out a very simple way of doing that. I said I will show you. If I want to add a single bond here, and I want the bond to be long, I stop doing this. Stop adding extra bond. This pattern is wrong. Okay, so this I'm doing is wrong because it's showing red. The
Sorry, sir, your screen is not showing.
okay, let me check. Okay, check back, you see it. Are you seeing it?
No screen showing. No, sir.
Maybe it's your network is showing.
Okay. So I was trying to explain that adding extra solid bond is not ideal, is wrong to do that. Let me add somebody. So what you just need to do is, I discovered that the bond length is fixed. So what we just need to do is to unfix the bond length because it's fixed. Just go to your come to structure. Okay, go to objects. You will see that in objects the fixed length is still good, meaning that any length you are drawing is fixed. So just unmark it by clicking on that good, it will go off. So this simply means that you can draw any length of your choice. I can use this and draw any length of my choice. I can now draw any length of my choice without me adding more bonds. Hope that is clear with you guys. Is that clear?
Yeah, it's fine.
Okay.
Sir, can you recap, please?
Oh, I was trying to explain the issue some of you encountered on increasing the length of the bond, which we are drawing more bonds. So I discovered the means to do that, which I said stop adding more bonds like this. Like stop adding more bonds like this. If you want to draw a long bond, what you just need to do is you come to your objects. In your objects, your object will appear to be like this. In your objects, you will see that this place is fixed. The fixed length is sticking good. Just unmark it. When you unmark it, you will see that the object is no more thick good. That means the length is not fixed. So you will now choose the length you want to draw. So you can now draw any length of your choice because you have removed it from fixed length. You can now draw any length of your choice. So that is the point we are trying to create. I can now make this length to be very long. I can draw any length of my choice I want to draw without me adding more bonds. So I promise to clear that off. All right. So let's quickly come back now to ChemSketch. Hello? Can you hear me?
But that we did.
All right. So let me, I'm done with what I was running. So let me come back to ChemSketch. ChemSketch is also easy to use. So for you to do that, it's very easy. Pick up your benzene, drop the benzene, pick your cyclopentane, attach to the benzene, pick up your single bond, include a bond here, click on the bond, make it double bond, and make it a double bond. Then pick your oxygen, type oxygen here, oxygen at this point, and oxygen at this point. Then use your plus sign. I would advise you, if you are doing reaction scheme, please use ChemSketch. Yes, because it helps you to do reaction calculation, which I'm coming to do that next. So pick up your plus. This is your plus. So here I'm not typing the plus, I just pick the plus. Then pick up your benzene. That is the benzene. You include your benzene. The next thing you are going to do is now I was trying to explain about these two reaction arrow. Here is just to show the arrow, but this is to label the arrow. So pick up this reaction arrow and click on it and paste. Now for you to label the arrow, to label it by putting the reagent up and the reaction condition down, pick up the blue one, which is reaction arrow labeling. Once you click on this reaction arrow labeling, you come back to the arrow and click on it. It will open up a dialog box telling you what you want to write down, what you want to write up. So at the top is aluminum chloride. Once I just put aluminum chloride, it will on its own make the 3 to be subscript. Then I want to write the reaction condition 70. At the right part, you will see degrees Celsius. So I'm not typing degrees Celsius. I will just pick my degrees Celsius from here and I will say OK. So once I say OK, it will appear on the reaction arrow. Then the next thing is for me to write the product. The next thing is for me to design my product. So hope you are following.
Yes, sir.
Okay. It is an easy one. It is not difficult. So what I will do is I just want easy for me, so I will erase here for myself. Then I will make here a double bond. Then you have this, and you also have this. I'll make here a double bond. So the next thing is I'll look for my O. So this is my O. This is my O. Once I put O here, it will show OH. So I'm done. So quickly, you now compare which one is faster, which one is easier for you to use. You go with the one that will be faster and easier for you to operate. So which one do you prefer?
ChemSketch, sir.
ChemSketch will be better. ChemSketch will be better. So and it's very easy. It's very easy to use. Then you can continue with others. I will just copy this. I will select it. I will copy it. I will paste. So I will paste it here. I will just drop it. Then continue again. I can also copy this and paste. I will continue with it. Then if I want to edit it, if I want to edit this one now, I will just click. Once I click on it, it will, okay, no, don't do this. If you want to edit it now, go back to your reaction calculate, go back to the reaction labeling, click on the reaction labeling and click on the arrow. So right here you can edit it to say H2SO4. You change from 70 to 200. You say okay, and it will change. Then you write your products. You write your products. So I believe with this you can be able to develop reaction scheme for your sentences. The problem we have that we only have few persons who have done work on sentences, because when you do sentences you need to now characterize what you have synthesized, and in Nigeria here we have just few places for characterization. Characterization is very expensive. That is why you barely see some work on chemical sentences. But if you check online, you will still see some persons who have done work on sentences. So this is to conclude our reaction scheme. Now I can still use my ChemSketch to generate the name, just because it can generate name. Since the structures are not complex structure, I can use my ChemSketch to generate their names. So when you are done with others, you just copy it and paste in your Word. All right. So do you have any question? If you have a question,
Yes,
all right.
It's too early to ask.
No,
I
go ahead.
wanted to know if this reaction, maybe after first or second reaction, you miss a track of how the structure of the product will look like. This software, is it going to show that there is a mistake, or is it going to correct the structure if mistaken? I don't know if you understand my question.
It's not really clear.
Like,
Do you want it to
I
predict your product for you?
first to check if it's actually correct. I mean structurally. If the product is what is supposed to give.
Okay.
That is from the reaction.
Okay.
Like now I have two, one. So
Yes.
how am I sure that the product I have is what I'm supposed to get?
Okay.
Like, is the software to tell us that this is what we are supposed to get?
Okay.
Because it seems to everything, we compute everything manually.
Okay. I understand your question. I'm going to answer it, but then how many minutes we have left? I don't know. Someone can check. Let's see how many minutes we have left.
9
Okay. Good.
9 minutes.
Now, what we are doing here with ChemSketch is to write the chemical equation of our sentences, the sentences that we have already written down by ourselves. You don't already use your hand write the chemical reaction for paper. We're going to use ChemSketch to just draw it, so that we can copy from the ChemSketch to your Word where you are typing your work. Now, the ChemSketch cannot predict if the product you wrote or the product you claimed is correct. It cannot tell you if the reactants, if these two reactants can actually give you this product. So ChemSketch cannot do that. But ChemSketch will work with what you give to him. So he's working with what you input, because you are the one drawing the structure. But there is a package that does what you are asking for. Can you hear me? Hope you can hear me. Hello. Oh. Mr. Austin, can you hear me?
Yeah, I can hear you.
Okay.
Yes, sir.
So what I'm saying is that there is a package that does what you are asking for. I wanted to bring it to this training, but I noticed that I have given you guys enough courses. So I am trying to leave that for the phase 2. Now, that one is called synthesis modeling, whereby I have a target molecule and I don't know how to synthesize that molecule. We have a software that you can just put in what you want to synthesize. That software will help you and break it down to the starting raw material. It will build what we call synthetic tree based on retrosynthesis algorithm. I don't know if you are with me. So this ChemSketch cannot build that model, but in the phase 2 of our training, I will be introducing that software to you. With that software, if I want to synthesize benzoic acid, I will just put in benzoic acid, probably the structure. I will draw the structure of benzoic acid and insert in the software. The software will then perform a retrosynthesis by building a tree that will comprise of the steps, each of the steps that will lead to the synthesis of benzoic acid. So ChemSketch doesn't do that. The ChemSketch is just operating based on what you give to him, what you draw. It does not correct your reaction if the reaction is right or wrong. I hope I have answered your question.
Yeah, very clear.
Okay. So would you like to witness how that software works?
You already said next.
Yes. Yes.
Next,
In the next phase,
so
by February.
that
Yeah, by February.
because I just imagine. Is that just an imagination? I was even thinking that it would be possible here, but thank God there's another software for it.
It's a good one. Okay, so but when we come back for the next session, I'll be doing reaction calculation fast, quickly in the next session. Then I will now end with reaction mechanism. So you will enjoy the reaction calculation because it's a bit related to what you are still asking, but you enjoy how it will be. It will be very nice, and in fact you enjoy it. We'll be using ChemSketch for that. So let us quickly, if there is no more question.
Okay, Henry, before this thing, our time's us out. We are listening slow. I want to know this our ChemSketch. Unlike we can change from structure to what to name to structure to name through ChemDraw. In this ChemSketch, which tools does that? Yeah.
It can't do that. It can only change structure to few structure to name, only simple structures.
Okay, only simple structures.
Yes.
Okay, something like benzene.
Yes, all those small ones.
Okay, and where you get it is through which this thing here.
Where we are last week, we have done that last week. Go to tools. You will see generate.
Okay.
Name for structure.
All right.
Okay. So let's meet at the second session.